Have you ever wondered if you can actually predict the future, especially with something as famously wild and unpredictable as the weather? Well, it turns out the answer is kinda, yeah, especially when you've got a little help from AI. Today, we're going to pop the hood and see exactly how a machine can sift through decades of old weather reports to predict next year's rainfall with, frankly, breathtaking accuracy. All right, let's dive right in.
So just look at this. This right here is our final destination. A super clean, simple application that gives you a clear forecast for rainfall in the year 2026. Now, it looks pretty straightforward, but believe me, behind this simple window is a really fascinating journey through a mountain of data, some clever code, and what is essentially a digital brain in training.
And that really is the big question, isn't it? How on earth do you go from a gigantic spreadsheet filled with old numbers to a reliable vision of what's going to happen in the future? Well, that's the puzzle we are going to solve together, step by step. We're going to break this down into four main parts. First up, we'll look at the raw ingredient, the data itself. Then, we'll check out the recipe, which is the machine code. After that, we'll watch the really cool part, how the digital brain actually gets trained. And finally, we'll come full circle to reveal that final forecast. Okay, first things first, you can't predict anything without data. It's the absolute foundation. Before an AI can even begin to think about what's next, it has to become an expert on the past. And that means we need to feed it a ton of information.
And when I say a ton, I'm not kidding. This whole process kicks off with a data set that covers a full quarter of a century. We're talking historical weather data for every single month from 2001 all the way through 2025. That's 300 months of history to learn from.
So what does this data actually look like? Well, for every one of those 300 months, the machine is logging these key factors: the average temperature, the average humidity, and of course, the one we really care about, how much rain actually fell. And you can see the story right away. A dry January at 22 millimeters is a totally different world from a soggy July at almost 300. So, here's the entire point of this first step. The AI's job is basically to be a detective. It has to comb through thousands of these numbers and find the secret connections. Is there some subtle link between the humidity in May and the downpour that happens in August? The machine's whole mission is to find that hidden pattern.
All right, so we've got our ingredients, that big pile of data. Now we need the recipe to tell the computer what to do with it. And that, of course, is the machine code. This is where we lay out the instructions.
Take a look at the very first few lines of the code here. You see all those commands starting with the word import? Think of this like a chef laying out all their knives and pans before they start cooking. These import statements are calling in powerful pre-built software libraries that are designed to do all the heavy lifting, all the complex math, so the programmer doesn't have to start from zero.
Next up, the code needs to clearly understand the problem. So it splits all that data into two buckets, which we call X and Y. X is basically our set of clues, things like the month, the temperature, the humidity. And Y is the one single mystery we're trying to solve, the amount of rainfall. Simple as that.
And I love this part because it shows that code isn't just about crunching numbers, it's also about design. This chunk of code you're seeing is basically the blueprint for that final app we saw at the beginning. It's designing the window, the layout, the table that will show us the forecast. It's making sure a human can actually understand the result.
Okay, so we have the data and we have the recipe. Now for the most amazing part of this whole process, training the digital brain. This is where the computer stops just following instructions and actually starts to learn.
The specific model we're using here is called a random forest regressor. Now that sounds complicated, but here's an easy way to think about it. Imagine you have a team of a few hundred weather experts. Each expert, or decision tree, looks at all the past weather data and makes their own prediction. Then, the random forest model just takes a vote, averaging all their opinions together to come up with one final super accurate forecast. It's wisdom of the crowd, but for computers.
So how does it learn? Well, we do something pretty clever. We split our 25 years of data, we give the AI about 80% of it, and we call that the training data. This is its study time. It gets to see all the clues and the real answers to learn the patterns. Then, we keep the other 20% hidden away. That's the testing data. This is the final exam. We show the model the clues from that data and ask it to predict the rainfall, and then we compare its answers to what really happened to see how well it learned its lessons.
After all that complex setup, all the data preparation, all the logic, you might think the learning part would be pages and pages of code. But look at this. It's one single line, model.fit. That's it. That is the light switch. That's the command that says, okay, digital brain, take everything we've given you and start connecting the dots. The magic really does happen right there.
And with that, the training is done. We've gathered the data, we've written the recipe, we've trained the brain. Now it's time for the payoff. Let's finally see the forecast that this entire process has been building towards for the year 2026.
And here we are, right back where we started. But now, when you look at this simple window, you get it. You understand the incredible amount of work humming away behind the scenes, the decades of data, the carefully crafted code, that fully trained AI model, all working together to create this one clear screen.
So, how well did our AI do on its final exam? The model's accuracy, which basically measures how close its predictions were to reality, is a staggering 99.83%. I mean, let that sink in. That is nearly perfect. In school, that's not just an A+, that's acing the final and getting extra credit.
And this table gives us the actual numbers, the final prediction. Based on every pattern it found in that historical data, the model says that July of 2026 is going to be the wettest month by far, with almost 314 millimeters of rain. Meanwhile, February looks to be the driest, with less than 20.
So, what are the big takeaways from all this? Well, first, the model is clearly pointing to a peak monsoon season right around July. Second, its average mistake is less than 3 millimeters. That is an incredibly small margin of error. And third, and this is the most important part to remember, this whole forecast isn't just a guess. It is a direct result of the patterns discovered in 25 years of real-world weather.
And that brings us to one last big question. If we can apply this method to something as messy and complex as the weather and get this kind of accuracy, just think about what other complex problems are out there just waiting for us to uncover their hidden patterns. If we can predict the rain, what's next?